So let's take a look at example 8 where we apply a lot of the things that we just learned. It says in a certain state, license plates each consist of 2 letters followed by 3 digits. So there are basically license plates in the state, and the first 2 things are going to have to be letters, A and B, and the third, fourth, fifth positions can be any of the digits. For example, 1, 2, 3. Okay. Now it's asking for how many license plates are there in total, and it's not telling me whether repeats are allowed or not. So I'm going to assume that everything goes, and so I'm going to assume that license plates such as AA, 111 for example, are totally fine. They're totally okay. So I'm going to calculate how many license plates there are next. In order to do that, I'm going to visualize what a license plate looks like again. So I'm going to have basically 5 different things to choose, and when I choose the first character, it can be chosen from any of the letters in the alphabet. And in the English alphabet, there are 26 possible choices, possible ways. Okay. Now this applies again to the next character, which has to be also a letter. Now, however, once you get to the third position, you can no longer choose letters. Now you have to choose digits, and the digits are basically the 0, 1, 2, all the way to 9. Basically, that's 10 of them. Okay, 1 through 9 is 9, plus the 0, which is the 10th one. And we have to do that again for the 4th and the 5th location. And that's because repeats are basically allowed, we're assuming, because they didn't say anything otherwise. So now, what's the total? So using the multiplication table, or the multiplication rule, the total is going to be 26 times 26 times 10 times 10 times 10. Which gives 676,000 possible license plates. Okay, so keep in mind that this 676,000 number represents the license plates where repeats are allowed. Okay, so that's the end of that one. So all I did was basically design a little graph, and you can write words to supplement this in case you're asked, but basically I wrote some words and I explained to you in voice that this is the solution. Okay, so now part 2 is how many different license plates are there where there are no repeats in terms of letters or digits. Okay, so let's try to kind of imagine the same situation again. So we have our 5 character license plate, and the first time you pick the first thing, the first character, there are 26 letters available. So let's say you picked T right here. Then you can no longer pick T again. So the next time you go to pick another letter, you have 25 letters available, and let's say you choose, I don't know, A. Okay. So next you have to pick a digit, because you're out of letters. The first 2 positions are filled with letters, whereas the rest of them are automatically going to be digits. So next you're gonna pick, I don't know, let's say 8. When you started, you had 10 choices. 8 is gone, now you have 9 choices. So let's say you pick 5. So now 8 and 5 are gone, and now you have 8 choices left. Let's say 0. Okay, so how many possibilities are there? Well, 26 times 25 times 10 times 9 times 8. So basically, again, using the multiplication rule, we can determine this amount. So that gives us a total of 468,000 possible license plates without repeats in their digits or their letters. So obviously, if you compare the answers from part 1 and part 2, you'll find that there's less license plates in part 2. That's because, you know, you're taking out all the ones that have repeats in them. So that's basically the end of that problem. Okay, let's think about example number 9. It says, suppose there are 3 routes from Burning Hall to McGaw Hall, and then 5 routes from McGaw to Monroe. How many ways is it possible to travel from the first hall all the way to the last hall? Okay, so let's make a summary. So there are 3 ways from BH to GH, and there are 5 ways or 5 routes from GH to MH. So the total is gonna be 3 times 5. So that's how many ways? 15 ways or streets or routes from the BH to the MH. And again, using the multiplication rule, I'm getting that answer. Okay, so it's a pretty straightforward problem. Nothing crazy going on there.